back to the Comptia Network Plus course. Wi-Fi Protected Access, or WPA2 pre-shared key. These are both essentially another form of basic security that's really just an add-on to the specifications, even though you can totally lock the vault. As I mentioned in the previous sections, WPA2 pre-shared key, PS key, is a better form of wireless security than any other basic wireless security method I've talked about so far. And note that, did I say basic? But if you're using only MAC filters and or WEP, and you find that interlopers are still using your network and dragging down the performance, adding this layer of security should help tremendously, since it's a better form of access control than either of those measures. Wi-Fi Protected Access, WPA, is a standard developed by the Wi-Fi Alliance, formerly known as the Wireless Ethernet Compatibility Alliance, WECA. WPA provides a standard for authentication and encryption of WLANs that's intended to solve known security problems. The standard takes into account the well-publicized air snort and man-in-the-middle WLAN attacks, so of course we use WPA2 to help us in today's security issues. The PSK verifies via a password or identifying code, also called a passphrase, on both the client machine and the access point. A client gains access to the network only if its password matches the access point's password. The PSK also provides keying material that TKIP, or Advanced Encryption Standard AES, uses to generate an encryption key for each packet of transmitted data. Although more secure than static WEP, PSK still has a lot in common with static WEP in that PSK is stored on the client station and can be compromised if the client is lost or stolen, even though finding the key isn't all that easy to do. It's a definite recommendation to use a strong PSK passphrase to include a mixture of letters, numbers and non-alphanumeric characters. With WPA, it's still actually possible to specify the use of dynamic encryption keys that change each time a client establishes a connection. The following screen shows that if you choose WPA2 Personal on the Linksys AP, you can enter your passphrase. It's really called WPA2 pre-shared key, but whatever. You have to choose TKIP or AES as the encryption, and by now you can choose up to 64 key pretty tight. WPA's mechanisms are designed to be implemented by current hardware vendors, meaning that users should be able to implement WPA on their systems with only a firmware software modification. Certificates and PKI. WPA2 can use the Extensible Authentication Protocol Eap method for authentication. Eap isn't a single method, but a framework that enhances the existing 802.1x framework. The Eap framework describes a basic set of actions that will take place, and each Eap type differs in the specifics of how it operates within the framework. These variables include things like whether they use passwords or certificates, as well as the ultimate level of security provided. Some of the Eap methods require that certificates be used as the credential during authentication. This means that to implement those methods, you must have a public key infrastructure (PKI) in your network. A PKI requires a certificate server that issues certificates to your user and their devices. These certificates, which consist of a public-private key pair, must be securely installed on the devices and renewed at regular intervals. In symmetric encryption, the two encryption keys are the same, just as they are with WEP keys, but in asymmetric encryption, the key used to decrypt is different from the key used to decrypt. In PKI, symmetric keys are used, and the keys are called public-private key pair. Certificates are binding regulations of a public-private key pair generated by a certificate server to a user or computer, as long as the two parties trust the same certificate source, called a Trusted Certificate Authority (CA). They can trust the certificate they presented with for authentication. These keys can also be used for encryption and as digital signatures. Despite the other uses of public-private keys, our focus here is the use of certificates as a form of authentication and authorization, and as a means of identifying the device or the user. This is considered the highest form of authentication and authorization when compared to names and passwords. What all of this means is that as long as the AP or controller and or the station or user trusts the CA that issued the certificate is trusted as a means of identification as well. EAP, Extensible Authentication Protocol, EAP, is not a single protocol, but a framework for port-based access control that uses the same three components that are used in Radius. A wide variety of these include certificates and PKI or even simple passwords. PEAP, Protected Extensible Authentication Protocol, also known as Protected EAP or simply PEAP, is a protocol that encapsulates the Extensible Authentication Protocol EAP with an encrypted and authenticated transport layer security TLS tunnel. It provides only a server-side PKI certificate to create a secure TLS tunnel to protect user authentication. EAP Fast works in two stages. In the first stage, a TLS tunnel is established. Unlike PAAP, however, Eap Fast's first stage is established by using a pre-shared key called a protected authentication credential. In the second stage, a series of type length value TLV encoded data is used to carry out user authentication. Eap Tls. EAP Transport Layer Security. EAP TLS is the most secure method, but it's also the most difficult to configure and maintain. To use EAP TLS, you must install a certificate on both the authentication server and the client. An authentication server pair of keys and a client pair of keys need to be generated first, signed using a public key infrastructure PKI and installed on the devices. On the station side, the keys can be issued for the machine itself and or for the user. In the authentication stage, the station along with the authentication server Radius exchanges certificates and identify each other. Mutual authentication is a solid, beneficial feature which ensures that the station it's communicating with is the proper authentication server. After this process is completed, random session keys are created for encryption. Pre-shared key. Finally, a pre-shared key can be used to secure wireless transmissions. This is the most labor intensive as it requires all the devices use the same key as the AP, and the keys be changed frequently to provide adequate security. Summary. Like rock and roll, wireless technologies are here to stay, and for those of us who have to depend on wireless technologies, it's actually pretty hard to imagine a world without wireless networks. What did we do before cell phones? So begin this chapter by exploring the essentials and fundamentals of how wireless networks function. Springing off that foundation, I then introduced you to the basics of wireless radio frequencies, RF, and IEEE standards. We discussed 802.11 from its inception through its evolution to the current and near future standards, and talked about the subcommittees who create these standards. All of this led into a discussion of wireless security, or rather non-security for the most part, which we went over in detail. We finished the chapter by bringing up to speed on TKIP, WPA, WPA2 security solutions, important tools used to protect the wireless lands of today. So I hope you like this video. If you like listening, please consider sharing and subscribing. Thank you.